grade 10s, grade 10s. This is going to be module number 12, and we're going to look at how to name ionic compounds. Now, I have to warn you that this is probably the first module where you're going to have to really do quite a bit of in-depth work to really understand these concepts. It's going to be tricky for us to figure out how to do a little lesson video, but what I need you to do is I really need you to use your resources, okay? Read the textbook section, watch some of Tyler's videos, and actually try to understand the concepts as we're going through. So this whole concept of naming compounds is called nomenclature. That's basically what that word means, okay? And it's a set of rules for naming chemical compounds. So the first thing you need to do is when we're deciding to name a compound, we have to decide which category that compound's in. There are only two categories, okay? And you remember on your periodic table where the metals are and where the non-metals are. So all you need to remember for the first part is that if you're making an ionic compound, you're going to take an element from the metal side, add it to an element that's a non-metal, and that's what creates an ionic compound. These are things like sodium chloride and magnesium phosphide, anything from the left and something from the right. Fairly easy to name. I'm going to show you how that works and how the ratio of which these ions come together to make a compound that's ionic. These are the salts that you know. These are the compounds that when you dissolve in water, they have charges to them, so they create electricity. You learned that in grade 9. And so all you need to be able to identify is if it's belonging to the left side and the right side, it's a metal and a non-metal. When they come together, they make an ionic compound. The physical and chemical properties of those compounds are very unique. All right, they have very strong bonds, and so they have high melting points, high boiling points, and those characteristics they have in common. These are what we're going to name first. Okay, we're going to spend the whole week on naming ionic compounds because they're a little tricky when you look at the charges putting them together. Then the next part of nomenclature, so the second part of the package, is a little bit easier and a little more fun. We're going to look at the second part where it's about naming the covalent molecules. These are the ones that we can make using the molecule kits. It's funny, it's a molecule kit. We call covalent molecules molecules, okay? And so they're all made of non-metals put together. So this is carbon, this is hydrogen, and this is called methane. 1 carbon, 4 hydrogens. This one right here is our good old familiar water made with oxygen and hydrogen. Remember, hydrogen belongs to the non-metal side of the periodic table. These are all the molecules, so non-metals and non-metals together. So when you're looking at doing all of the naming rules for this whole unit on nomenclature, all you have to do first of all is identify, is the elements that make up the compound metals and non-metals together? That's ionic, or are they non-metals and non-metals? And just so that you know, metals and metals never come together to make compounds. You don't have calcium calcide or magnesium. That doesn't work, okay? So it's either ionic or covalent, and we're going to do the ionic ones first. Okay, here we go. Ionic compounds. This is what they look like by definition. I'm going to split this module into 2 parts. The first part is the easy ionic compounds, okay? The second part is the one where we call them multivalent, because if you remember on the periodic table, the one that you filled in from my study solution sets, I've added in a few of the elements in the middle, the transition metals that have more than 1 ionic charge. Why? Because it makes an atom more stable, and sometimes those ones that have lots of electrons that are in the middle of the periodic table, they can be happy by either losing 1 or 2 or 3 or 4 electrons to become different ions. This is what's on the periodic table. Look at all these different ones in the middle. It's a little more complex, and yeah, we're going to show you how to do that, but that's the second part. We got to learn how to do it first, okay? The easy ones first. So by definition, a compound that is ionic is a metal and a non-metal held together by an electrostatic attraction, and what do? They form ionic bonds. These are very strong bonds. What does it look like? Here's a sodium, here's a chlorine. Sodium has 1 valence electron, chlorine has 7 valence electrons. Sodium's in group 1, Chlorine's in group 7. So have your periodic table with you when you're doing this. So all you need to do is refer back to it. You never have to remember or memorize the periodic table. All you need to do is be able to find the element on the periodic table and then do the work that's involved. And you remember that anything in group number 1, group number 2, that tells you, the group number tells you how many valence electrons an atom will have. Okay? Sodium loses an electron, chlorine gains the electron, sodium becomes a positive ion, chlorine becomes a negative ion. That will come together to form a compound called sodium chloride, and they form an ionic particle, meaning you've got an ionic bond. And it's that attraction between the positive and negatives that create this very strong bond. Okay, so here we go. Let's show how this works for the first one. Go ahead and just fill things in as you need to. I just don't want to keep our video running for too long, okay? So for the first one, let's see. Let's do some ionic compounds. Again, everything we're doing today is metal and non-metal. Here's your Bohr diagram for sodium, okay? Here's your Bohr diagram for fluorine. You can see that sodium has 1 valence electron and fluorine has 7 valence electrons. How do you show that? You can show it by dots, you can show it by X's, it totally doesn't matter, okay? Sodium's in group 1, there's my 1 valence electron, my Lewis dot structure for sodium. Fluorine has 7. 1, 2, 3, 4, 5, 6, 7. Okay? What happens? This sodium, metals want to lose electrons. It wants to give it to fluorine. Metal will become a positive ion. Okay? How do we show that? We've got our sodium with a 1+ charge. Now I have my fluorine. Remember, you're going to do it in the square brackets. Show the 7 electrons around it. And if it's gained an electron, it now has 1 more negative thing than a positive thing. Fluorine has a negative charge. Sodium, fluorine together will create a compound where you have 1 sodium and 1 fluorine. And that is called sodium fluoride. Okay? That's how you make it. And again, how I've shown you how to do this with your Lewis dot structure to make the ions, the arrow shows the transfer of electrons, and then you write your final compound as the ratio that those ions are in. All of that is very specific, so do a really good job with figuring out your understanding for all of these, because very quickly we're going to get to the point where you're just going to say sodium fluoride 1, 1, that's the compound, okay? But you understand from grade 9, you learned about electrons, you know how to do a Bohr-Rutherford diagram. Now you know that to make an ionic compound, you need a metal and a non-metal, and then the metals want to lose electrons, and the non-metals want to gain electrons, and then we look at the ratio of them together. See how all this chemistry builds? Very quickly it'll turn from grade 10 to grade 11, and so you need to be able to do this chemistry and understand it so that you can do the hard stuff when we actually get to grade 11, when it becomes much more complicated. Okay, so break it down into steps. Take a break when you need to. That's my laundry finishing. Okay, here we go. Let's do the next one. Let's write the compound for magnesium and sulfur. I use my periodic table. I can draw a Bohr diagram if you need to. Do as many or as few as you need to. Magnesium has 2 valence electrons. It's in group number 2. Sulfur has 6 valence electrons. Let's show all 6 valence electrons. Remember, you would fill up the 4 first, then go back around and fill up the other ones. This electron can go here to make it happy. This electron can go here to make it happy. Isn't this cool? Okay, so very good. My next step, I write down the ions that form, because this is an ionic compound. Okay, magnesium is a 2+ charge. I'm going to add that to sulfur. Fill in your valence electrons now that are completely filled. It has a 2 negative charge. Where do you write the answer? Just write it down here. M, G, and S. Can you see that one compound with a 2 negative charge and one atom with a 2+ charge, put them together and your lowest ratio is 1 to 1, okay? Again, the arrow will show the transfer of an electron from the metal to the non-metal, and 2 ions get formed. How do you name these compounds? They're very easy. You take the name of the metal. It's on the left side of the periodic table. It always comes first. Then you take the name of your non-metal, which is on the right-hand side of the periodic table. Take the ending off and add IDE. Okay, let me for a second take you to the textbook and just show you what you're going to be looking at. You've got ionic compounds here, okay? How does that get formed? There's your nice Bohr-Rutherford diagrams. Show the electrostatic attraction between them. That's what a particle of sodium chloride will look like, okay? It's actually a lattice structure. It's a crystal. So all of these ionic particles are crystallized structures. Okay, talks a little bit about dissolving. That'll be important when we get to grade 11. Okay, properties of ionic compounds. Again, you can see some of them here. Now, let me scoot to section number 5.7. You can see here you've got some bluestone, which is copper sulfate. We can make that in the lab actually. And then it talks a little bit about naming your compound. Okay, so magnesium and chlorine would be magnesium chloride. Aluminum and oxygen would be aluminum oxide. All you do is add an IDE to the non-metal atom ion, which is in that particle. Okay, charges, don't memorize, just use your periodic table. The periodic table group number tells you the number of valence electrons. From the valence electrons, you figure out what the ionic charge would be, and then you put them together in a ratio that makes sense. Okay, so here we go. I'm going to show you how this makes sense where we do the zero-sum rule on the next page of the notes, but again, your explanation is really good here. So work through it, and I call this easy math. You just got to make it equal to 0. So does this make sense right here? If you have one thing with a 2+ charge, 2 things with a 1- charge, you need to have overall a 0 net charge for that particle. So that makes sense that the ratio that these ions are going to come together in is going to be a 1:2 ratio. One thing with the 2+ charge, 2 things that have a 1- charge, put them together, and overall the sum of those charges in that particle have to equal 0, and so then you've got a zero-sum rule. Okay? Oh, did you see I'm wearing my Readers at Home shirt? Yeah, put that on today. I forgot to do that for my last video, even though I had it. All right, there's your textbook. You're going to refer back to that when you need to. Okay, let's scoot to the next page here and keep going, and then I'm going to pause after I teach you the zero-sum rule, and then I'm going to show you in the second video what you do with the metals that are in the transition. Okay, here we go. Lewis dots diagrams are simply a more convenient way to decipher the electron transfer so you don't have to draw the Bohr-Rutherford diagram. Again, I know that you know how to do that. So do you have to, I don't want to go live, what's that? Right? We can now skip that step you learned in grade 9. You understand it from grade 9. Now let's make it the easy version. If you can't do the easy version, then sure, do all the rough work you need to do from the Bohr-Rutherford diagrams, but you'll eventually want to speed things up, so try to get that understanding away before you need to, okay? We allocate the electron placement in a balanced fashion. I maybe could have figured out a few more of these blanks, write them down for you. Okay, something else to note before we move on. This is called a superscript, and this is called a subscript. Okay, superscript is the one at the top. It indicates the charge on the ion. A superscript down below indicates the number of ions that are going to be in that particle. Very important. Okay, superscript tells you the charge of the ion. That's like the second step in making the compound. And then you figure out the ratio of those 2 ions. That's what comes into play with the superscript. Okay, so here we go. Examples of Lewis dot structures, great. Nitrogen, 1, 2, 3, 4, 5. Maybe I should do X's for these. 1, 2, 3, 4, 5, 6, 7. Oxygen is in group number 6. 1, 2, 3, 4, 5, 6. Does it matter where your blanks are around your atom? No, not at all. It totally doesn't matter, okay? Calcium is in group number 2. It has 2 valence electrons, okay? So here we go. Let's make a compound called calcium, or that's going to have calcium and chlorine in it. We know it's going to be called calcium chloride because the metal is going to come first. The non-metal, you're just going to change the ending to IDE. So let's do this, speeding it up a little bit. Calcium has 2 valence electrons, 1, 2. Chlorine has 7 valence electrons, 1, 2, 3, 4, 5, 6, and 7, okay? Calcium is an ion that has a 2+ charge, right? A calcium electron here is going to go to this one down here, but what are you going to do with this other electron? Calcium isn't going to be happy until it gets rid of its 2 electrons. So I'm going to have to add in another chlorine ion. So for it to be happy, this electron is going to go here. So calcium gets rid of its 2 electrons. One chlorine takes one, the other chlorine takes the other one. So I know that I need to have two chloride ions okay, coming together in a ratio that is CaCl2. Okay, does that make sense? I'm just putting a box around it because that's my answer. That refers to the fact that I have 1 calcium and 2 chlorines. Okay, so I could say that 1 particle of calcium chloride has 1 ion of calcium, 2 ions of chloride, and I show that using the subscripts below. That is the ratio of the ions. The ions come together and make that bond, and now you've got a particle. Okay, so the charges show up above. That just shows you the ratio that you need to have a compound that goes together properly with 0 sum overall, and then you've got a compound called calcium chloride. Okay, I'm going to pause the video right here, and then I'm going to show you how to do the 0 sum rule in the next one.